In this problem, we want to find the exact value of the 6 trig functions of theta, and we want to do that using the given information. So in number 10, we're given that the angle is in quadrant 2. So what I'm going to do is I'm going to draw the bow tie triangle that would be in quadrant 2. Because if my angle lands there, then that means initial side's on positive x-axis, terminal side would be in quadrant 2. And so this would, my bow tie triangle would look like this. Now, we are given the tangent of theta. Remember that theta will be the reference angle, so it's the one closest to the origin inside of the bow tie triangle, or the reference triangle. And tangent is equivalent to y over x, or opposite over adjacent. So the opposite side of the triangle should be a negative 15, and the adjacent side should be 8. Well, hold on a second, right? Because we are in quadrant 2, so actually y is positive there, it's x that's negative. So I want to make sure I note that the y would be 15 and the x would be negative 8. And then now I'm going to use Pythagorean theorem to find the hypotenuse. And so I'm going to get 64 plus 225. And that's going to be 289. And I believe the square root of that is 17. So now we know that our hypotenuse is 17. So that tells us that the sine of the angle is going to be opposite over hypotenuse. So 15 over 17. Cosine of the angle is going to be adjacent, which is negative 8 over hypotenuse. We already know tangent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Sorry, that's an 8. And then cotan is the reciprocal of tan. So those are the exact values of the 6 trig functions. And note that if you weren't told directly what quadrant you were in, you would use the given information to figure it out. So we know that in this case, we know that tangent is negative. So that means that x and y have different signs. So that would put me in either quadrant 2 or 4. So that's something that you can use to help you with these.